So lesson 12, this would be the paper you picked up today. So look at it. This is printed on there, the warm up. You within your groups, I'll give you, I don't know how long you need, maybe 2 minutes to figure out which expressions, if any, are perfect squares. So decide in your groups, not all of them are perfect squares, but which ones are. Oh, table 5, can you tell me one of the perfect squares, if any? So just give me one. All right, class, do you agree that this one's a perfect square? Yeah. Anyone disagree? Okay, Ryan, why do you disagree? These are different. That's why it's not a perfect square. Now, I can see why some people, like, I think they're just getting it confused with a difference of squares. That's not the same thing as a perfect square. Okay, a difference of squares is really just talking about when it's in this form. That's how you factor it. So not the same as a perfect square. A perfect square would have to be the exact same thing. So table 5, do you want to maybe pick a different answer? Yes. Number 1, do you guys agree that that one's a perfect square? Yeah. I heard a no. Oh, okay. Yeah, does an order matter in addition? No. Does not matter. X plus 5 is the same thing as 5 plus x. So this is a perfect square. They would give you the same meaning of print. I remember there was one question on the homework where it said, like, are these all equivalent at x's? I would say just plug in a number for the x, except for maybe 0, maybe like a 1, and see, like, you get the same answer. 1 plus 5 is 6, 5 plus 1 is 6. So yeah, they're exactly the same. Not in this one though. It would give you different answers. Okay, good on that one? Yeah. All right, table 7, can you tell me another perfect square? Number 4. Class, do you guys agree? What is wrong with, why is it not a perfect square? There's no parentheses, so it's not a perfect square. I would say because only the 3 is square. Like the x is none. So it's not what we call like a perfect square. We're talking about quadratics. Table 7, do you want to pick a different one maybe, now that we know it's not that one? Because of that reason. 3, class, do we think that's a perfect square?
Yes.
All right, good. Now that it has the parentheses and it is squared, that whole expression is a perfect square now. Questions on that one? All right, table 8. We're between 2 options, so don't tell me you don't know. Maybe number 5, class, do we agree?
Yeah.
Okay, we have some mixed answers. You could look at your notes like I showed you that there was a pattern and see if it fits that pattern. Again, I don't really like that way. It does work. I just don't like memorizing random stuff like that. So what I would suggest for this one is factor it and see if your answer looks like 1 or 3. Okay, so the only way I know how to factor a trinomial is by the diamond method. What would go on top of my diamond? 16, what would go on the bottom? What are 2 numbers that multiply to 16 but add to 8?
4.
And
4.
Since they're exactly the same sign and everything, then yeah, this one is a perfect square. So x plus 4, because that's what the factors one looks like. I think that's much easier than memorizing that. So, but up to you. Questions on that one? So let's see, is the last one a perfect square, table one? You're saying yes? So, okay, so let's see. If I set up my diamond, what goes on top? What goes on bottom? Can you think of two numbers that multiply to 20 but add to 10? I couldn't either. I don't think that one is factorable. But here's some numbers that multiply to 20. I don't think any of them could ever do that. Regardless, it would have to be the same exact number for it to be a perfect square. So number 6 definitely is not, because I don't even think it's factorable. It's definitely not. Questions on the warm up? Okay, great. So recognizing perfect squares, that is on your test, so we'll get that one for her on the test. Now, let's do this next activity. Some of it is review, so I think 1 through 3 is good practice for the test, and hopefully you're remembering what we're learning so far. That was I need to review. These ones down here are a bit more of a challenge. But remember, if it's a trinomial, what's the only way we know how to factor trinomials? The diamond method. So like, for example, in number 4, I don't have a C to know what goes up here, but I do know of my B. What's my B? -1. And we know that the rule is it's supposed to multiply to the top, but add to the bottom. Now look, it's showing my answer is going to be a perfect square. So what are two numbers that are the same exact number that add to -20? -10, -10. That would be a perfect square. And then now I can figure out what my C was. What's -10 times -10? So then that would fill in number 4 here and here, because it already has a minus there. Does that make more sense?
Yes.
Okay, so fill in the rest of the table with your groups first together. It may or may not be the same order. I might end it up again. Otherwise, just be ready. So table 2, what'd you get when you factor number 1? Okay, good. Anyone disagree with that? All right, if you did the diamond method, it would look something like this. And you set it up, multiplying to 9, but adding to 6 is a 3 and 3. So it can be written as a perfect square. It's the same exact number. Questions on that? All right, table 3, what'd you get for number 2?
X minus 5 in parentheses squared.
All right, class, agree, disagree? All right, so then in case you didn't get that, it looks something like this for the diamond. 25 on top, -10 on the bottom. If you thought x plus 5, you need to remember since it's adding to a negative, that makes these both negative. Okay, questions on that? So now going the other way, but still doable. We learned it unit 6 actually. Table 4, what'd you get for number 3?
Um,
No? I don't think so. Really, what you should be doing is this in your head. So expand it first and then FOIL it out. So far, I agree with you. Not finished yet. All right, class, agree, disagree? Okay, good. We actually did see that one on lesson 11, so I'll remind you. But yeah, that really is what you should be doing, is expanding it, FOILing it out. And, or if you memorize this, it does follow that pattern. So lots of ways you could have gotten to the right answer. But yeah, that's how you do it. Questions on 1 through 3, those we were reviewed. All right, table 5, we'll rotate the reporter one to the left now, whoever's the last. So table 5, did you get the answer for 5? For what goes here and here? All right, class, agree, disagree? All right, so I'm sure some people didn't get that far, but I think it's right. Let's double check. So based on what you're given, you initially can't fill in your A times B because C was blank, but you can fill in your B. What's B going to be? 16. And then we're looking for, because I know my answer is going to be a perfect square since I wrote it like one. I'm looking for 2 of the same exact numbers that add to 16, which is 8 and 8. And now since I know what those are, I know it has to multiply to the top, so 8 times 8 is, so that works. Questions on that? All right, now there is kind of a pattern going on. 6 and 7 are a little bit more tricky. I'm not gonna lie to you. But I can see why they're doing that because they're trying to get you to see a pattern. So we'll do 6 together. For 4 and 5, did you notice, like, how did you easily figure out that what these numbers would be? What could you do? Or maybe hold that thought for a second. Let's set up the diamond. So on the top, I don't know what that is because there's no C. On the bottom, it should be, and I know it's going to be a perfect square because that's how they wrote the answer. What numbers, and they have to be the same exact number, add to 7? Now, I told you before that we shouldn't use decimals really, but so we're going to kind of make it the equivalent fraction. And I know for some of you that's hard to think of. So you could also use decimals for that. But what did you do to figure out it was 3.5? You divided it by 2. But just in case you didn't know, that's the equivalent fraction. Okay, we did 7 divided by 2. So I'm actually going to change that to 7 over 2. But yeah, it is 3.5. So I'm going to make this 7 over 2. And then now that we know what these are and they have to multiply to the top, what's 7 over 2 times 7 over 2? 49 over 4. For multiplying, you just multiply straight across and simplify at the end. But you can't simplify because there's nothing in common between those two. So that's what fills in this. My C is the 49 over 4. Or maybe you wrote it as a decimal, but put the fraction in there too. And then my X is whatever my B was divided by 2. And that's really what we did over here, right? Didn't we do 16 divided by 2 to get 8? Yeah. And negative 20 divided by 2 to get negative 10. So on that very last one that has variables, and if you've noticed like that pattern, usually when it's all variables, they're like showing you some sort of like rule. How did we find so this time B is just B. b is. How did we find these two again? And all of them so far, we divided by 2. So I'm gonna write it as b over 2. Because that's what we would have to do to whatever b is. And then we have to multiply it to get the top. So we just multiply straight across. What's b times b? And what's 2 times 2? 4. I'm also gonna write it like this, and maybe you'll see why in the next step. So we could write 4 as 2 squared, right? And we can write this whole thing as taking half of b and squaring it. So for my c, I'm gonna write that final thing, and you'll see why I prefer that in a second. And then for what fills in my perfect square, it's gonna be c over 2. So questions on that? I'm sure you're probably thinking why. Just write it down. I'll tell you about it. But with all the numbers, at least that makes sense. So that's good. Okay. So I told you we're going to be doing something what's called completing the square. And the process that we just did is actually part of that process for completing the square. So I'm going to have you write down some steps. First, make sure this is all written down. I'm going to split the thingy. Go on to the next page. But wherever you have room, I want you to write these steps. So these are going to be the steps for completing the square. I'm a big step-by-step person. I always follow the steps in my head every year when I teach the same stuff. So it helps me, I think it would help you. But there's the steps for completing the square. So step 1 is to rewrite it as ax squared plus bx equals c. So moving the c to the other side, no longer in standard form. Step 2, we're going to take half of b, square it, and then add it to both sides. So that's step 2. Oops, is what we did in that last activity. Each time we took half of b, and then we squared whatever we got. And now if I add it to both sides, that's going to give me what I need, which is a perfect square trinomial. So step 3 is factor the perfect square trinomial. And then step 4 is take the square root of both sides and solve for both cases. So make sure that's all written down, and then I'll walk you through what they did, okay? Following these steps to a T. May kind of is, I don't really know how she knew to pick 16, like I don't really know what she did. So I'm just gonna say follow these steps, which is what Diego did. So first step is to rewrite it as ax squared plus bx equals c. So right now it's in standard form. I'm gonna do what we did earlier and write what we did in each step. So first step is given. The second step is after we rewrote it according to step 1. So C is the 9. If we want to move it to the other side, we have to think, well, how can I cancel it on the left side? And then whatever you do on one side. So that's why when you moved it, it became negative. So you still have to do your inverse operations. You can't just like make it equal 9. It has to be subtracting 9 on the side. Okay, so we rewrote it. Step 2 is to take half of b. So what's my b so far? So I'm taking half of 10, which is what? And And then we're squaring it, which is what? And that is what they're adding to each side. All right, on the left side, there's nothing to combine it with. On the right side, -9 plus 25 is 60. So I'll put step, like our step 2 next to it, so that if you need an example, there's an example. They took half of B, squared it, added it to both sides. So what that creates is a perfect square trinomial on the left. So like when I factor it, so this step, I would say factor. When I factor it, I get 25 on top, 10 on the bottom. What numbers complete the diamond? So multiply 25 to add to 10. 5 and 5. So that's how they got to here. Maybe I'll dump this down. Maybe it goes better with that. All right, but anyway, so factoring it and then writing it as a square enables us to then do the rest of it, which is take the square root, kind of like how Jada did on that last note sheet. The opposite of squaring something is to, and whatever you do on one side. So then I get x plus 5 equals, what's the square root of 16? 4, and then also the -4 too. So that's what it means by solve for both cases. Because when you square root something, there's technically 2 answers, the positive and the negative. All right, and then when you solve for both, so subtract 5 on each side, 4 minus 5 is -1. Over here, subtract 5 on each side, except this time it's a -4. I get -9. So that's how you do it. Any questions? All right, May, she did get the same answer, but again, I can't for the life of me think how she knew to get 16, like to add 16 to both sides. So I'm just not really gonna worry about May's option. If it makes sense to you, great. But you wanna have a perfect square trinomial to then factor it. Questions on that? Do you want to see one more or do you want to try? Okay, anyone vote for want to see one more? Okay, there's a few more hands. So we'll do one together and then I'll have you try 2 and 3. So the 2 and 3 will be the you tries. All right, but number 1, I'm gonna follow the steps exactly. First step is to rewrite it. So how do I get the C to go on the other side? Subtract it. Because for this method, we don't want it in standard form. We want the C to be alone on one side. So the constant has to go with our inverse operations. So I get x squared plus 6x. What's 0 minus 8? So that's step 1. Step 2, I need to take half of b. So what's my b? And what's half of 6? And then I need to square it. What's 3 squared? And that is what I'm going to add to both sides. So then it becomes x squared plus 6x plus 9, because on the left side, there's nothing to combine it with. On the right, what's -8 plus 9? It is 1. I'm going to write it like that for your notes sake, so that way you can see like why it became 1, because we added it to both sides. So then the way I'm writing it probably has too many steps, but I'm just doing it for your notes. Okay, so then on the right, we get 1. So that creates a perfect square trinomial on the left. I factor it now according to step 3. So that one we've seen before. So what multiplies to 9 but adds to 6? 3 and 3. So I can write it as a square, x plus 3 squared like that, equal to 1. And now that it's like that, I can continue. I can square root each side, because that's opposite of squaring. So now the x plus 3 is alone. And what's the square root of 1? 1 and -1. So step 4, you have to solve for both cases, positive and negative. Otherwise, you just get one answer, and most of the time there's 2. So, then you solve. How do you get rid of the 3? And you'll actually do that for both of them. And then I get x equals, what's 1 minus 3? -2, and then -1 minus 3. -4. Okay, so those are the 2 answers for that first example that's on your paper. Questions on that? Okay. I'll leave it here for reference, but now you try it and follow all the steps. You get stuff, look at the steps. If you don't understand the steps, come and ask me. But yeah, I'll give you a few minutes and we'll go over it. When you finish those 2 you tries, you can take out your Chromebook and work on your puzzle pieces, but do try these first. All right, but answers I put at the top of each problem. So if you got it right, great. You can quietly work on your practice while I explain it to everyone else. All right, so number 2, follow the steps. First step is to rewrite it as ax squared plus bx equals c. Is it already like that? So good. Step 1's already done. Step 2, I need to take half of b. What's half? Well, b is 12. Half of b, and then square b, we get 36. This work I usually do like either in my head or on the side. But yeah, take half of b, square it, then you're adding it to both sides. So I get x squared plus 12x plus what I told you we were adding to both sides, 36. Stop talking. On the right side, what is 13 plus 36? Remember, we have to add that to both sides. Sorry, I know what it is. 49. So then, that's what we get. Questions on that? So now we're on to step 3. We need to factor the perfect square trinomial. So diamond method would look something like this: 36 on top, 12 on the bottom. What multiplies to the top but adds to the bottom? Good, and they're both positive. And we write it as x plus 6 in parentheses squared. It would have to be written in that form so that way we can move on to step 4, which is to take the square root of both sides. Essentially, we're solving for x. Whatever you do on one side. So now the x plus 6 is alone. And it's equal to what? What's the square root of 49? And
-7.
good, you have to solve for both situations. So then add a 6 on each side. And really that's what we, not add 6, I should subtract 6, that's how you get it to be 0. Subtract 6 on each side, and that's what I'll end up doing over here too. So that the x is alone. What is 7 minus 6? And -7 minus 6. So that's how we get these answers. So there. Okay, this other one I'm probably gonna have to do down here, just because I'm not in room. But number 3 was x squared minus 2x plus 3 equals 83. So first step, we need to rewrite it. Is it in the form it wants? How can I make it into the form it wants? Good. So regardless, you need to have the x terms alone, like, you need to have the constant on just one side, so even if there's one on the other side already, that's fine, just do what you need to do to make it cancel. What's 83 minus 3? 80. Now I need to take half of b, which, what is half of -2? And then we need to square it. What's -1 squared? No. 1. And then you add that to both sides. So then my left side is now a perfect square trinomial. My right side, 80 plus 1 is 81, and that makes that a perfect square too. So then factor the left side. What multiplies to 1 but adds to -2? What are the only numbers that multiply to 1?
-1.
And then if it adds to -2, they both must be, okay, good. So x minus 1 squared equal to 81. Now we're just solving for x. So opposite of squaring something is, do that to both sides. The x minus 1 is alone. What's the square root of 81? Good, so that's why you have to solve for both cases. I will still do, I did tell you. To but yes, that's how we get there. Question? Okay.